To find the average velocity, we need to take the displacement and divide it over delta t, which is the change in time. To find the average vector velocity, we need to find the x and y components of the position vectors. Right? And the question already gave us the x and y components of both position vectors. This is the x and y components of position vector 1, or R1. And this is the x and y components of position vector 2, which is R2. R sub 2, R sub 1. And I wrote it here. See, for the second one, it's 45.1 meters x hat, which is x components, minus 28 meters y hat, which is the y components. We did the same thing for the first position vector. The next thing we want to do is find the change in time. So we just subtract the final time from the initial time, and we'll get 98.9 seconds. So next thing we want to do, since we know what our x and y components are, and we know delta t, we can plug it into our equation. So in the numerator, we have r sub 2, which is position vector 2, right here, and then we subtract that from position vector 1, which is this right here, and divide all that by 98.9 seconds. After that, we want to combine like terms, or combine the x components with the x components, and the y components with the y components. And when we do that, we'll get this right here, 43.8 meters x hat minus 29.3 meters y hat. And then after that, we want to divide each component. So we want to divide the x component by 98.9 seconds. Then we also want to divide 28.93 meters y hat by 98.9 seconds. We have to do that because we want our answer to still be in unit vector notation. So after we do all that, for our velocity vector, its x components will be 0.44 x hat minus 0.30 y hat meters per second. To find the acceleration vector, we need to take the difference in velocity divided by the difference in time. So we need to find the x and y components, and the question gives it to us. So our x component for the initial velocity is 1.3 meters per second, and it has no y components. And for the final velocity, we have negative 0.3 meters per second y hat, and it has no x components. So now the next thing we want to do is find delta t. So we just subtract the final time from the initial time, and we'll get 1 second. So now we have all the values we need to solve for the acceleration vector. So we just plug in our values. So it will be negative 1.3 meters per second y hat, which is the final velocity, minus 1.3 meters per second x hat, which is the initial. All that divided by 1. And so we divide each component by 1, and we'll get the same answer. And then afterwards, we need to rewrite our answer in unit vector notation. So it would look like this. Negative 1.3 x hat minus 1.3 y hat meters per second squared. And this is the x and y components of our acceleration vector.